Hi everyone, welcome back to another Calculus 12 video. Today we're doing 11.3, which is the substitution rule. And again, like the theme of this course, you'll probably recognize that name. You've done the substitution rule before, but with algebra, and now we happen to be doing it using antiderivatives. But it's still the same old thing as what you've done before. So let's dive into, we're just going to do a couple of examples. Let's dive into the first one. I'm going to zoom in so you can see it well. We're taking or finding the antiderivative of this function. Actually, let me bring back the other one for a second. Notice on the one on the right, the dx is off to the side. I could have had on the left this dx off to the side with a 1 in the numerator. But since it's just a 1, I've stuck the dx at the top. But please note that it's exactly the same thing. So if we are dealing with something like this, we basically can take the part that's complex or confusing and we can use substitution in order to deal with it. So if we have something like that, I could say let u equals 1 minus root x. So kind of like what we've done in the past with our algebra skills, we can do that with this. But sort of off to the side, we're also going to find the derivative of this. So if we want to look for du dx, so the derivative with respect to x, because x is what we have embedded within the equation, then the 1 obviously would be gone because it's a constant, but this is like saying negative x to the power of 1/2. So we know from before that the derivative of that is just going to be negative 1 at the top and then 2 root x at the bottom. Okay, and although this may not make a whole lot of sense to you right now, I'll show you in a few minutes how it does make sense. We're going to take this negative and also this 2 here, and we're going to cross multiply that up here, and we're going to move the dx up there. So what we end up getting is 2, actually I'm going to make it negative, so negative 2 du equals dx over root x. And I know right now you don't know why I just did that, and this probably isn't making a whole lot of sense to you, but stay tuned. We will get to the reason why we're doing that and what to look for in order to know what to do with this. So there's a reason we're doing that, but let's just shove that off to the side for one quick moment, and then let's come back to this stuff. I'm going to draw a little line down here just so we can stay organized and you're clear on what to do with this. So also notice that I could rewrite this again to say, well, I still have my dx at the top and I still have my root x here, and I'm going to try to show you this right off the bat. Dx over root x, like that's the same thing as what you're starting to see the reason why I've set things up the way I did on the right. And that would be times at the bottom root x times this u, because I made all that stuff equal to u. So I know I use these different colors and it's looking a little bit messy, but I hope that this, and that's really awful looking, but I hope that that's kind of making sense. So it's dx over root x times u, and I've purposely substituted in u there for a reason you'll see in just a moment. Okay. We notice, or hopefully you notice, that dx over root x is the same thing as negative 2 du. Actually, let me use it even a different color. Let me do the negative 2. I'm going to stick in front of here, so sort of like shoved off to the side so we don't need to worry about it. And then I'm going to stick the du. No, I want to use pink for that too. I'm going to do the du off to the side as well, so just off to the side here. And then we're going to take a look at this, like all that would be left here would be 1 over u. So I hope that that kind of makes sense to you. The negative 2 and the du, I just separated them and shoved them off to either side, but they could have been like up here instead of the 1, right? I've just sort of built that into one step, so I hope that that's clear and you're able to see that. So that allows us to deal with this in a more simplified manner rather than all this stuff that we had at the start, but we do eventually need to plug that back in according to the rules of substitution, which we've done before. So at this point, I'm going to switch to just one color. I hope that's okay. But we have -2, and then if we are looking for the antiderivative of this, 1 over u, going back mentally to your derivative rules and all the stuff that we worked through, we know that that's the same thing as ln u. So I have ln u du here. So again, this is that -2 out front. This is that du from there. So it allows us to clean things up a little bit. And the last step is simply substituting back in what we had let u equal to here, the 1 minus root x. So we would have -2 ln, and it's going to be an absolute value because we need to have a positive there, times du. And then remember that we always put a plus c at the bottom when we are dealing with the integral, because there might be a constant that's there at the end, and we need to account for it. Okay, so I hope that that is helpful. Again, you can hit pause, you can rewind and rewatch that part if you need to, and if not, let's dive into the next one, which is finding the antiderivative of sine root x over root x of dx. And again, we want to substitute things in. So I'm going to do this off to the side. We could let u equal root x. Okay, I could do the integral of sine u over u dx, but I want to take the derivative of this and sort of keep that in mind while making my decision on what to do with the stuff on the left. So let's do that. Let's do du dx. So we're taking the derivative of this with respect to x. And we know that that is equal to 1 over 2 root x. Again, because that's just x to the power of 1/2, we would bring forward that 1/2 and subtract off 1. And that's how we end up with this. And so what ends up happening there is, again, I kind of just want du on its own. I don't want to mix up the du's and the dx's. So I'm going to cross multiply to bring this dx to the top here. So I'm going to have dx over root x. And I also want to bring the 2 over to the left. So again, to clean things up a little bit, so we have 2 du equals dx over root x. So looking back at the last one, that's kind of the same type of pattern as what we did here, right? So you sort of get the dx's and the x's together, and you cross multiply to get the other stuff to the left side of the equation. So now I'm just going to sort of leave that off to the side. And then we'll take a look at this part. I'm sort of like, you're looking at patterns to help make things easier for yourself. So if you look at the pattern from the last one, I hope I'm not jumping back and forth too much, but notice that we took this dx over root x, and I also got that on the right side. So that's kind of the similar type of pattern that we're trying to use here. Like, notice that I got this dx over root x over here, so I want to get that over here as well, like dx over root x. So I want to leave those alone because I know I can substitute in the 2 du for that. So keeping that in mind, although I could have done sine u over u, I'm just going to leave it as sine u, and then I'm going to make this like so obvious. Obviously, this is not how we would write it. It would be sine u dx over root x, but I'm trying to make it super obvious to you that this is what is going on. I have the sine u, so I'm trying to make it visually very obvious where we're headed with this. So hopefully you're sort of seeing that. And again, if I have this dx over root x here. Well, I just found dx over root x is equal to 2 du. So I can do the same thing as before. I can take that 2 du, I'm going to use a different color to do this, and I can separate them. And I like to do this as a habit, stick the 2 in front of the integral. So then I have sine of u, and then at the end, I have that du from right here. So you can sort of see that this is starting to look much nicer, much cleaner than what we originally had, which is the whole idea behind this, is to try to simplify things and make life easier for ourselves. Okay, so then we're thinking backwards, working backwards. I want to take the 2 would be there regardless, that's why I've separated it and left it off to the side, but when we think backwards and take the antiderivative of sine u, we'd have negative cos u. So I'm going to stick the negative with the 2. So I'm going to have negative 2 cos u. And then because I've taken the antiderivative of it, it would just be plus c, right? So the du is gone because we negative cos u is the antiderivative. And then we need to substitute back in. So we let our u equal to root x up here. So I just need to plug that back in, negative 2 cos root x plus c. And so that's what we would eventually get for our final answer. Okay, so hopefully you find that that is not too bad. Page 511, numbers 1, 2, 3, 4A, C, E, and 6. That's your work for today.